Okay, so for the example, so we have the mass of the nucleus minus the total mass of the number of protons. We know the number of protons is said, so if you want, you could write this as said times the mass of the protons, and it's all in the brackets, so plus number of neutrons is often written as n times the number of neutrons, mass of the number of neutrons times the mass. Okay, so the mass of the nucleus, they told us in the question, was 3.016049 U's. And then minus brackets, we're doing radioactive isotope of hydrogen, so it's 3,1, which means there's one proton. So 1.007825 U's, you would multiply it by however many, in this case 1, plus, and if there's one proton, that means there's two neutrons. So 2 times brackets 1.008665 U's, close the brackets, do the math, and get the mass defect to be negative 0.009106 U's, where the negative means mass is missing or lost. Not really lost, it's missing. It's changed into binding energy. Okay? So that's mass defect. And that's part A. Part B wants to know what's the binding energy. If it doesn't say in joules or in electron volts, then the easiest thing to do is binding energy is equal to 931.48 mega electron volts per U times the mass defect. So in this case, 931.48 mega electron volts per U times that 0.009106 U's. Do you need to keep the negative? You can if you want. If you keep it, then at the end of the answer, then you say it's because the mass has gone missing. If you don't keep it, that's okay too. The negative is really just telling us that the mass has been changed into energy. And so we end up getting 8.48205688 mega electron volts. Okay, so that's the binding energy. Now, what if I had asked for what's the mass defect in kilograms and what's the binding energy in joules? So you could get it in kilograms if you had memorized that big number, that 1.66 whatever, and multiplied it by the U. But the easier way is you already know how to switch from mega electron volts to joules. You could switch from mega electron volts to joules with your 1.602. So 8.48205688 mega electron volts is really times 10 to the 6th electron volts. And then to switch to joules, joule per electron volt, you don't want to divide, you want to multiply. So 1.602 to the negative 19 joules per electron volt. So you punch all this in your calculator. So 8.48205688 to the positive 6 times 1.602 to the negative 19. Except I didn't punch in 1.6, I punched in 1.5. 8.48205688 to the 6th times 1.602 to the negative 19. And you get 1.358825512 to keep Gabriel happy, times 10 to the negative 12 joules. Okay, so now we have our binding energy both in electron volts and in joules. We have our mass defect in U's. Now we want it in kilograms. How do we get it in kilograms? Use E equals mc squared. So m will equal that E you just found divided by c squared. So take that number, divide it by 2.9979 to the 8th squared, and you should get 1.511922.075 to the negative 29 kilograms. Okay? So you don't have to ever then memorize that 1.66, etc. that I've never memorized. It's much easier to just remember 931.48. Okay? Or I think it is. All right, so I'd like you to do some of these for over the weekend as well. And so they are in your textbook on page, so there's 4 on page, oops, be good if I had this in the screen, on page 642, numbers 1 to 4, and on page 654, numbers 1 to 3. So there's 7 of these just to give you practice, and then there's 4 of the half-lives. So a total of 11 questions over 3 days, actually 4 days because it's a long weekend. That's not too bad. That's like 3 questions a day. All right, have a good weekend. Try not to miss class too much on Friday.